Welcome, folks. We'll get started in about 3 minutes. Going to get started in about 1 minute. All right, welcome, folks. Let's get started. Welcome to the 20th day of remote learning. Today's joke is, what kind of shoes do ninjas wear? Sneakers. Happy Monday. Simplify that like button to show your support. Thank you to Alan for today's joke. And a reminder, if you have a joke to suggest, please email it to me so that I can share it with the world. I hope you enjoyed the Primer YouTube channel and also the Primer movie that got shared on Friday. Today's YouTube channel is called Smarter Every Day, and they just did a really great video about simulating the behavior of flocks of birds. And they have some video of the behavior of real flocks of birds, and then they've also talked about doing simulations on a computer of it. It's some really neat stuff, and I've done some of the computer simulations as well. I might actually see if I can add one of the ones that I did to um, the classroom so that you can see it. Sorry, I'm just having notifications pop up here. It's a little distracting. At any rate, so today we are going to be focused on some review of concepts from the entire course. We're going to spend most of this week, maybe all of this week, doing this review work. As I've mentioned before, the goal here for us in remote learning is to make sure that everyone is well prepared for grade 10. So we're going to be going through things. We're going to be making sure that you understand what's going on, answering any questions that you have. The homework for today is to complete a quiz that is online. And so it's on Google Forms. It'll tell you whether you get the answers right or wrong. It's all multiple choice. And each of the questions in the quiz is a question from a previous year's EQAO. So normally we'd be using this to get prepared for EQAO. Obviously this year we won't be doing EQAO, but it's a really good indicator of how well prepared you are for grade 10. So we want to make sure that we're on top of that, and we'll have a few more of these as we go. One quick note, when you do the quiz, there's a link at the top of the quiz to the EQAO formula sheet. And I would recommend that you use that. It's also the very first thing linked in the classroom lesson. So please have that open, use that as you're doing the quiz. You don't have to memorize the volume, surface area, and perimeter formulas. You can use the ones from the formula sheet. Of course, if you really want to memorize them, you're welcome to do that and do it from memory, but that formula sheet is available to you, and I'd encourage you to use it if you find it helpful. All right, so let's dive right in. The document called Day 20 Examples has the 6 questions that we're going to look at together today on the live stream. And I'm going to give you each question and a little bit of time to try it out before I do it here. And so that way you can check what you did, think it through on your own, and see how it goes. So question 1, Arabesque, which is a really yummy restaurant on Victoria Street. They sell 30 falafel pitas for $239.70. How much would 127 pitas cost? So you can go ahead and try this out, and then we'll see 2 different ways to do it. Once you have an answer, if you can post it in the chat, how much would 127 pitas cost at Arabesque? Thank you, Owen. Give people a bit more time. So we'll see if we can get 2 answers in chat for each question before we move on. Thanks, Adam. Thank you, Cooper. All right. So 2 different ways to do this. The simplest and most straightforward one is to just do 239.70 divided by 30, because that will get us the cost for one pizza or one pita, pardon me, and then multiply by 127. And if we do that, we do indeed get $1,014.73. The other way to do it, and I kind of hesitate to call it another way because it's really the same way in disguise, is to just set up a proportion. X dollars per 127 pitas is equal to $239.70 for 30 pitas. And if we set up this proportion and we solve, well, we want to get rid of the divide by 27. So we're going to multiply by 127 on both sides. And you can see that that's led us to exactly the same calculation, right? Oh, assuming that I wrote the numbers correctly, 239. So it's exactly the same calculation, 239.7 divided by 30 times 127. And so it will get us to the same answer. All right. So moving on to our second question. We have another ratios and proportions one. This situation, we have a bread dough that contains flour and water. There are 1,600 grams of dough. 700 grams of that is water. The dough is only made out of flour and water. We want to know how much flour is needed for 5,230 grams of dough. Give it a try. Once again, if you can type your answer into the chat when you're done, and we'll get a few answers in there before we keep moving. So once you have an answer for this one, just put your answer into the chat. We'll take a look there. All right. So it's taking a long time. I'm not sure if that's because people are finding this one tricky, and it does have a bit of a trick to it, or if you just need more time for the calculation. You can put a 1 in chat if you would like to see me work through this one. So again, that's put a 1 in chat if you'd like to see me work through this one before we get answers from the other students. Cooper, Owen, Adam, all ones. All right, cool. So this one is what I call an EQAO classic. And by that, what I mean is EQAO has a few tricks they just love to play. Now, you folks are lucky you're not going to have to do the EQAO, but EQAO chooses these tricks because they're tricks that happen a lot in reality when we start to use math to do these calculations. And this calculation that we've got right here is one that you or your parents may have been doing recently. I know coronavirus lockdown has led to a lot of baking. And so if you're trying to figure out hydration levels for dough, doing a calculation like this is exactly what you need to do. So the trick here is that the information that we're given is how much dough and how much water. We're not given how much flour in this original mixture. Now, the question that I wrote this from tells us that the dough is made up of water and flour. And so that gives us the information that we need because we can say weight of dough, or maybe I should say mass of dough, or sorry, mass of flour equals 1,600 grams of dough. And dough is the mixture. So then if we subtract 700 grams of water, what's left will be the 900 grams of flour. And so now when we set up our proportion, we can say, okay, there are 900 grams flour per 1,600 grams of dough. And I want to know in the same proportion, if I have 5,230 grams of dough, what is the amount of flour that I will need? So we're not going to solve this yet. That's just setting up the proportion. If you can type a 1 in chat if what I've just done there makes sense to you, or if you have a question, please go ahead and type your question into the chat. Thank you. All right, so we've been seeing some ones in the chat. So now we just need to go through and solve this proportion. A proportion is just an equation. This is x divided by something. So we're going to do the opposite of dividing by 5,230, and that is multiplying by 5,230. So we're using opposite operations, and because it's an equation we're solving, we're going to do the same thing on both sides to keep it equal. So once we do that, we will get that x equals, so this side, these two, 5,230 divided by itself is 1. 1 times x is x. There we go. And then over here, we have 900 times 5,320. Oh, did I type my, yeah, typo. 230. Let's change that. 230 divided by 1,600. And we get that we will need 2,941.875 grams of dough. Or sorry, grams of flour. And you can't see that. There we go. And so we can check this. So if we go 2,941.875 divided by 5,230, we get 0.5625. And if we do the division on the other side, 900 divided by 1,600, we also get 0.5625. So now we know that both proportions are equal. All right, what questions do you have about that? Feel free to put them in the chat. Type me a 1 if that is all making sense to you. And in the meantime, just to note again, the trick here was that we didn't have the amount of flour in the first dough. We had the total amount, we had the amount of water, we had to do the subtraction to find the amount of flour. All right, seeing lots of folks in the chat saying that that's making sense. Cool. So we'll move on to our third example. Here we're looking at some decimal and percentage stuff. So question 3, 4, and 5 decimals and percentages. And I wasn't able to remember exactly how much of this we did. I know it's something you've seen in grade 7 and grade 8. If we didn't do a lot of review of it in the early days of the course, I apologize. Hopefully what we do now will help to make up for that. So this first part here, I know that we did do. And so it's asking us, what is 1/5 as a decimal? And then what is 1/5 as a percentage? So go ahead, see if you can figure that out. Type your answers into the chat. Thank you, Adam. Thanks, Jawad. Thank you, Owen. All right. So to get the decimal, we just do the division. 1 divided by 5, we get 0.2. And to get a percentage, we take the decimal and we multiply by 100. And remember, percentage literally means per. Cent is the French word for 100. So it's per 100. So if we multiply by 100, 0.2 times 100, we get 20. And this sign is telling you that 20% is really 20 per 100 or 20 over 100. So that's what the percentage sign is. It's a fancy way of showing it's a fraction per 100. Okay. Solve that one. As always, if you have questions, throw them up in the chat. We're going to keep moving here, but I'll keep an eye on the chat and help you out. So our next one, still on percentages, but a different kind of question now. What is 23% of 12.464? Go ahead, give it a try. Put your answer in chat when you're done. And if you do have any questions as we're going, feel free to add them to the chat as well. Thanks, Jawad. You've got it. Thank you, Alan. Thank you, Adam. All right. So the key thing here is to know that we can convert the percentage into a decimal by just moving the decimal place 2 spots to the left, or in other words, dividing by 100. So 23% is literally 23 over 100. So if we make that into a decimal, we get 0.23 multiplied by 12.464. You might know that the English word of is mathematical shorthand for a multiplication. And if we do that multiplication, we end up with 2.86672. All right. So we're going to keep moving again. And as always, if you have questions, feel free to put them into the chat. Question 5, we're looking at sales tax here. Sales tax in Ontario is 13%. So if we have an item that costs $14.77 before tax, and the tax is 13%, we want to know what is the final price. What is the final price? Let's go ahead and try that one out. And we'll talk about it in a moment. Thank you, Alan. Thank you, Adam. Thank you, Owen. All right. So here we again have a very small trick, not a major one. There's 2 ways to do this. So one way is to calculate 0.13 or 13% of 1477 exactly like we did in the last question. If you do that, you get $1.91.1. And then you can add those two together, or add that to the original price, and you get $16.69. And there's a 0.1 in there, but because with money we only go to cents for most purposes, we'll usually leave that out. So the final price, $16.69. 2 things to note. First of all, it's not okay to just add 1477 here. I actually need to start a new calculation. And the reason is that we have an equal sign. The amounts on both sides of the equal sign have to be the same value. This is equal to this. It's not equal to this plus 1477 more. So we always want to start as a new one here. Or alternatively, I could have done this plus 1477, and then on the right-hand side, I would also have the plus 1477 and calculate it through. So in other words, write my whole calculation at once. So I mentioned there was a little trick. Well, the trick is that if we have a price and we want to add 13% to it, what we're really asking for in the end is 113% of the original price, right? We have 100%, that's the price without tax, plus 13%, that's the price with tax, for a total of 113%. So an alternative way to do this question is to do 1.13 instead of 0.13. So now we're looking at 113% times 1477. And if we do that calculation, we get to $16.69 right away. So a little trick to speed things up there. All right. So as usual, if you have questions, please go ahead and ask them in the chat. We're going to look at our final example, question 6. And question 6 is asking us, what is the area and perimeter of the shape below? So I'm going to try and draw this shape here. So it's 3/4 of a circle. There's the center of the circle. We can see that the radius is 2 feet. But this part of the circle here has been squared out. We get a nice square right angle. So the two questions are, first of all, what's the area? And second of all, what is the perimeter? And I'm going to ask you, when you do this one, for the area, start by writing the formula that you're going to use to put the whole thing together. All right. So, there's a circle in here, there's a square in here. How are you going to use those different pieces to calculate the overall area of this entire shape? And then once you have that overall plan written in formula form, then go ahead and see if you can do the calculation. For now, we'll just start with area. We'll get to perimeter later. Go ahead, take some time to try it out. Once you have an answer, put it up in the chat. I'm going to start the question myself in about 30 seconds. I won't say anything. I'll just start writing. Ooh, push that down. There we go. Give it a try. Jackson, just saw your comment there. I have just taken a look at my email and I don't see anything from you. I did have an email from you earlier that I answered earlier in the day. So if you haven't looked at your email in the last few minutes, I definitely take a check at that. But I think that I've answered everything that I have from you in my email there, Jackson. So, all right. And Rise and Aiden are saying the same thing. So right now I have an email from Jordan that's still sitting here to answer. And that is the only one. So Aiden, assuming Rise is Jordan. Aiden, I'm not sure whether I've missed something from you somehow. If so, could you resend that, Aiden? Okay. Oh, good, Jackson. I'm glad you got it. Okay. All right. So back to this question. So I always like to make the plan first. So I'm looking at this, I'm going, okay, there is a circle here. Actually, sorry, I'm going to give you folks some time to calculate. I'm going to write what I'm doing here. Once you have an answer, put it up in the chat, and then we'll talk about them. Thanks, Jawad. Thank you, Owen. All right. So taking a look here, the original plan is we have a circle, but it's not a complete circle. It's only 3/4 of the circle. So that's looking at the area outside of this square, but inside the shape. So 3/4 of the area of the circle, plus I want to add the area of the square. Then once I have that plan in place, I'm going through using the formulas. So area of the circle is pi r squared. Area of the square is side times side, and the side is the radius. So I've just reused the variable r. You might have used b, you might have used variable s, lots of different things you could use there, but you'll get that format for the formula anyway. And then we can substitute in. We know the radius is 2, and we calculate, we get 13.42 square feet. If you do end up working somewhere with people who are using the imperial system, so if you are building something out of wood, in Canada we often use imperial measurements for measuring wood, usually not for metal, but often for wood. Then one thing to note is that square feet isn't expressed feet squared like we would with the metric system. So in metric, we'd have meters squared written like this or like this. But for the imperial system, which is feet and inches, we don't use this. Instead, we use SQ in front of it for square feet. It's a weird thing, but if you see it, I want you to know what it means. I'm not ever going to mark you wrong on a test or anything like that if you put feet squared like this, and I don't think any other teacher will either. But just so that if you see this SQFT, you know what it means. Okay, so if you have questions, ask them in the chat. If not, go ahead and try the perimeter here. And again, I'll give you about a 30-second head start, and then I'll do my calculations. And once again, if you can write in your plan. So what is the formula that shows your plan of how you're going to get this? Thank you, Owen. Thanks, Joanne. All right, so let's take a look here. So the overall plan for the perimeter is that we're going to do 3/4 of the perimeter of the circle because we go 3/4 of the way around. And then for the sides of the square, we're only counting 2 of them. This one here, this one here. These 2 don't get counted because they're not on the outside of the combined shape. Perimeter means the distance around the outside of a combined shape. These are not part of the outside, they're inside the shape, so they don't count for perimeter. So we only have two sides of the square, therefore 2 times s. So then I can simplify a little bit. The 2 with the 4 reduces it down to 2. So we have 3 over 2 times pi times the radius, which is 2, plus 2 times the length of the side, which is also 2. And when we calculate that, we do indeed get 13.42 feet once again. So we got the same number, although different units, right? This one was square feet for area. This one is feet for perimeter. And this has happened that we get the same entirely because it's a measurement of 2. If you redid this with a measurement of 3, you'd see that you get different values for the area and the perimeter. And in fact, this happens a lot when you have lengths of 2 in calculations, and that's because 2 times 2 is 4, but 2 plus 2 is also 4, and 2 to the power of 2 is also 4. So when we're dealing with 2's, we often get the same answer to 2 different calculations. All right. That is our final example for today. So those are all review from what we've done. Jackson, I'm actually going to answer the question in your email on stream just so that everyone's clear on it, because I think it's useful for everyone to hear. So what are you being asked to do for homework? In the classroom, there's a link to a quiz. It says EQAO review quiz. It has a number of questions that are like the ones we did today. There's also some that involve changing lines from slope intercept form to standard form or vice versa. And there's a little bit of simplifying of exponent laws as well. So they're all things that we've done. I'd like you to give them a try, hand in the quiz. It will give you feedback when you hand it in. So it'll tell you which ones you got right, which ones you got wrong. And if you got one of them wrong, it will show you what the answer is. And then if you have any questions about any of them, feel free to get in touch with me. I'm happy to follow up and give you some more information. So hope that that helps. I'll stick around here for another 30 seconds or so. If you have questions, feel free to put them in the chat. If you don't have any questions, if you could just give me a 1 in the chat so that we know that we're good. And again, if you're one of the last 3 or 4 people, if you can just leave the stream open until I end it instead of shutting it down early, because if we only have one person left and they want to ask a question, I unfortunately have to shut the stream. So I just appreciate you folks leaving it open for a little while longer. We can make sure that everyone gets their questions answered. All right, so Owen and Jawad and Alan, I'm seeing 1s from all of you. Thank you very much. That's really helpful to know that this made sense. On Wednesday, we'll continue. We'll have a second EQAO quiz, and we'll also have a little bit more of review, some different types of questions. Thank you, Adam. So Wednesday, we'll continue to push through and review. My goal over this month of June is really making sure that you're starting to feel really comfortable with these skills. We've obviously had a lot less class time than we normally would because of school closures. So I want to make sure that with these fundamental skills, people are really comfortable with them, and that when you get to grade 10 and you're in the same class as people who did math first semester and got to do, 5 days a week, 75 minutes a day, full regular course, their life running normally or mostly normally in most cases, that you're not way behind those people. So we want to make sure that you're ready, that you understand all the major stuff. There'll be a few little things that we won't get to, but I've made sure that all of the major critical stuff for grade 10 we've done, and we're going to spend some time zooming in on that, reviewing it well, and ensuring that you're ready. All right, folks. Thank you very much. We will see you again on Wednesday. And once again, the stream is going to be at 1 p.m. I've had some feedback that that's a better time for people. So we're just going to keep it at 1 p.m. from now on through till the end of the semester. Have a great rest of your day. Take care.